All right. Cool thing is this one, we're now doing our dilations. Remember, the dilations was the only non-isometric, if you want to say that, transformation. Remember that a dilation is the transformation that changes the size of the figure but not the shape. It is not an isometry. It's instead called the similarity transformation. And when you guys look at that, look, when this is drawn, what does it look like? Those end up staying parallel to each other, don't they? And doesn't that look like similar triangles? I can have my triangle here and my larger triangle. So really you can almost visualize what it's saying. Now, notice the lines that connect every pre-image to its point. They all will intersect at a given point. That is called the center of dilation. We will always dilate from the origin today. All right, we will not go, which remember is 0, 0. We will always do that. Now, we have a factor. That scale factor that we use tells us what we're going to work with. That's called the scale factor. But in your brain, think of it as your similarity ratio. It tells you how much bigger or smaller you're going to get. So it's a linear measurement that tells me if I'm going to get larger or smaller, and it always goes with our pre-image. Up here, they were just saying, hey, we could write a ratio. Notice this, P prime to Q prime goes to P to Q. Oh, wait, that is a similarity ratio. I take my corresponding sides and I put it over. So the cool thing is a dilation can reduce or enlarge, okay? So here's some rules. A dilation with a scale factor greater than 1, which means your numerator is bigger than your denominator, is called an enlargement. And you even talk about that with pictures. You do an enlargement or reduction of pictures. So we have enlargement, or it's also called an expansion, is another word that they use with this. Now, another one that we have is a dilation if it's less than 1. So if the denominator is larger than the numerator of the scale factor, it is called a reduction or a contraction. And a contraction, when your muscles contract, they come together and they get really tight. So it's a way of thinking about it. So then we have to be able to put this on a coordinate plane so we can be able to do this. Notice my P and my P prime right here. Notice there's a scale factor in front of it, and the scale factor we're going to use is K. So your arrow notation for any dilation is going to be the following: X, Y, and then notice each of your coordinates is multiplied by your scale factor. So it's going to be Kx and Ky. Now, here's a few things that are really kind of cool to know. If you have a negative scale factor, so if this happens, your pre-image will change size, but it also have a rotation. What does this mean? Well, look it down below. A dilation with a scale factor negative K is equivalent to first dilating a figure by the factor of K, then rotating at 180 degrees. Because remember, your arrow rotation for rotating 180 degrees is a negative X and a negative Y. So the negative of your scale factor changes it that way. So here's just an idea of what it would look like. So here, if this was my pre-image and I have a positive scale factor, notice it gets bigger. But if I have a negative scale factor, and it's really the same scale factor but with a negative, notice it got bigger, but it also rotated over 180 degrees. All right, now let's go ahead and fix a whole bunch of my typos. Tell whether each transformation appears to be a dilation in this part, and this would, of course, be a yes. The next one would be yes, because we're going from the smaller one to the larger one. We're dilating about that single point, so that's a yes. The next one is a no. Notice there's not that perfect one-to-one. This side and these do not correspond to similarity. And actually, if you're being careful, you're going to notice right here and here, that's also a no. They're not drawn the same. Now, if it was drawn a little more accurately, we'd have no problem with this. So now, how about if we actually get some practice with these? These are very easy to practice, and then we'll be almost done with these notes.